and distinguish polynomials. Identifying and distinguishing polynomials. So first we have to talk about what a polynomial is. Okay? So a polynomial by definition, we'll say the actual definition of it, is a did I say polynomial? Polygons. Polynomials is something we're doing in Algebra 1 right now.
Well, it's written on a tag, polynomials. Yeah, it's written on the board.
Did you have a good spring break?
Big oof. I did until that. So a polygon, excuse me, not a polynomial,
I'm still on.
big oof, is a closed figure with at least 3 sides, and those sides are made up of line segments. So a triangle is an example of a polygon. Now a polygon has no curved sides. It has no curved sides. So no sides of a polygon can be curved. They have to be straight. It cannot have any intersecting lines. And there are no gaps in the polygon.
In Spanish, I forgot her word. I really physically did not.
After the first page, how your last room.
She said, did you share?
Eat a tree
Wait,
branch.
so could I close
I
the
know.
Oh.
That's
I know, I
Okay. Hey, so an example of a polygon, I heard someone say triangle. That would be an example. Because there are no curved sides, they're all straight. There's no intersecting lines. And there's no gaps in it. There's not an opening. Whereas here, that's pretty close, but why would this be a non-example? Because there's a gap, okay? It's not closed. It's not a closed figure. This would be considered an open figure. So that would be a non-example. Non-example is an example of something that's not it, okay? Alicia, Kylie,
Sorry.
attention up here, please.
Random seating chart.
Example.
What's that?
A,
Soccer ball, kind of. What about diamond?
Can I try to make this in the trash?
a polygon.
Yeah.
No.
A
Sorry, what?
soccer ball.
What about diamond?
A diamond? So like this? Alright, let's think about that. Does this have any curved sides?
No.
Okay, not if Mr. Costa
Your
draws it
picture
better.
does.
Okay, not if Mr. Costa draws it better.
Just fix it.
Are there any intersecting lines?
No.
No. Are there any gaps?
No.
No. So it would be in fact a polygon.
Stop
Okay.
sign.
And a stop sign, which is an example of an octagon, it is a top of polygon. So an octagon would work.
I don't know how to draw that.
There's 8 sides, 6 sides.
Just draw 8
There's 8
different
sides
lines.
in a stop sign.
Well, yeah, you can't do that.
Okay. What about if Mr. Cossel
What about square? No. Not.
draws like a perfect star like that? Oh, let me
This
close
is
that up.
not a perfect
Is that would that be an example of a polygon?
Look at my stop sign.
Yeah.
Okay, correct. There's no curved sides. There's no curved sides. There's no intersecting lines. There's no gaps. What about this one? Would that be a polygon?
That's just intersecting lines.
No, because there's intersecting lines. Okay, so that wouldn't be.
And there's a gap.
And there's a little bit of a gap. No, there's not. Okay, so the overlapping ones. Okay, what about a circle? Where would that go?
The bottom example.
Non-example. Why?
Doesn't have curved sides.
It's curved.
You might
That's
want to
okay.
use the stop sign,
Okay,
yeah.
an oval or any sort of rounded object. Okay, that curved sides. Okay. Could I even draw one, get a little like funky like this, kind of make it more like a crown? Would that still be a polygon? Yeah, I think so. Okay.
I want to make a crown.
But if I do one like this, kind of like a spiral,
Part from board.
No. Senor.
No, it's not connected.
it's not connected. There's gaps and it's curved. Okay. So it's kind of breaking a couple rules there, right?
It's
Right.
not even a shape.
So hopefully we're kind of getting ideas of what could be and what is not a polygon.
Hey, even though it's not a shape, it could be whatever it wants to be because we're not talking about shapes.
They're
We're
just
talking about
shapes, for
polygons.
Christ's sake.
A
It's already
polygon
a
is a shape.
How do you know? That's
It's
not
Actually,
a
it's
shape,
a
that's not a
closed
polygon.
figure,
You
but
just
like
said that's not a shape though.
Dude,
What is
I'm
it
better
called?
with-
a spiral is not
Shut
a
up.
shape.
Voice it off.
Me too.
Voice it back off. Voice it back off. Thank you.
What?
We're going to talk about the definition of a vertex. We talked about vertices, well, the plural vertex, before with triangles and for different angles. So a vertex is
Each
going to be
point.
each endpoint of a side, okay? And it's going to be really each point of the shape as well. So it's each end point of a side to be a vertex. So raise your hand to tell me an example of a vertex in this polygon. Kylie.
B.
Okay, point B. Raise your hand to tell me another one. Okay, Nick.
A.
Okay, A. Let's get one more. Okay, just air. Okay, Kylie.
D.
And D. Okay, you really could have listed any of these points on here, right? Those would have been any of them would each be a vertex. Now consecutive. Consecutive. That means they go in order, right? They're one after another. We talked about consecutive numbers before, like 2, 3, 3, 4, 5, 6. Okay. Yeah. So consecutive vertices are vertices that are adjacent to each other. What do we say the word adjacent meant?
Next to.
Next to. It means they're next to each other. So if they're consecutive vertices, they're going to be vertices that are adjacent or next to each other.
It's taking like 5 minutes.
So like example A and example E. So point A
Dude,
and
slow
point
down,
E.
please.
You can't write adjacent.
Turn it
No,
into
I'll slow down
Mr.
a second.
Titus.
I'll slow down a second.
Okay.
Okay. Hey, so Nathan said point A and point E, vertex A and vertex E, those would be consecutive because they're adjacent, right next to each other. Okay? And Marley, point D and C would be another example.
Why can't we just call them adjacent vertices?
We'll stay with consecutive though, because we use consecutive a little bit more in this. Because we usually try to reserve adjacent for right triangle trigonometry. And
Are we
angles.
done
Hey,
with that?
why aren't they called angles instead of points?
Because the vertex is part of an angle.
Because it's
So
outside.
they're different parts. So an angle has 3 parts: the vertex and the 2 sides. And so the vertex is a part of that.
This is easy. We're learning about
So,
shapes. This is what we're
what would be an example of 2 non-consecutive vertices?
It's easy
Sophia?
now.
B. And listen.
Okay, B and E would be non-consecutive. They're not right next to each other. Okay, A is in the middle. Okay, so consecutive sides are going to be sides that are adjacent to each other. Very good.
I have a question.
Yeah.
Are there going to be any like hard stuff in this unit, like the radicals?
It depends on what you think is hard, but
There's
there's
a
going
lot
to
of
be some math.
charts
Are
in
there
here.
It's gonna be
radicals?
shape plus shape equals shape.
I don't think we have radicals in this.
Good.
Yo, Kylie.
Because none of this is gonna ever leave in my brain.
We might have a little bit of radicals, but not much.
What?
Is that a dexahedron?
Well, I just failed the radical.
Whoa. Graph
What
Hey,
size is a
so-
dexahedron have?
Somebody give me an example of consecutive sides here. Sophia.
Side BC.
Okay. Side B, C, everybody listen up.
Side DC.
Side B, C, and side D, C, okay? So this side right here, and this side over here, those would be consecutive. Somebody give me another pair of consecutive sides here. That would be an example. Okay? Nick, thanks for raising your hand. What's up?
B A A E.
Side BA, ooh, that was a terrible segment there. And side, you said AE?
Yep.
I agree with that. That would work. Okay. And there's a few other, there's quite a few others we could do as well, right? Okay. Yep, that would work. Okay. So there's plenty we could do. We're not gonna go through naming them all. Okay. So if we want to name a polygon,
People listen to alphabetical order.
not alphabetical, not necessarily. It can be,
Number.
but it's not always. So we list vertices in consecutive order.
Ooh.
So we just kind of follow along, we pick a starting point, and we can really start anywhere. We can start at any of these vertices, and from there, you go in either clockwise or counterclockwise order.
Start with A because it's the alphabet. That's how it starts.
Counterclockwise, one word. Yes.
I actually looked it up because I was wondering that as I typed it. I'm like, okay, I feel like I've seen it different ways. You can separate it, you can hyphenate it, you can make it one word,
I made it
and
one
apparently
word.
all of them are considered correct.
It
Which is
looks weird.
Well, I put counter. I didn't put N.
Oh, you put,
It's kind of
Really
like how
see
you spell
big,
color
smart.
and then color.
Okay.
Say it again.
I said big smart.
Can I have a other color?
How's that
Like
even?
pink? Sure.
okay,
I didn't hit him,
so
so it's fine.
if we were to name this one, somebody give me a starting point. Sophia.
E.
E, okay?
You start
From
with
E,
A.
does it matter whether we go to A or D?
No.
No, we can pick either one, okay? D would be going clockwise or counterclockwise?
Clockwise.
Clockwise. You follow the clock, everybody can look at the clock there for about 2 seconds and say, oh, it goes this way. We're gonna go this way here. Okay? If we went to A, which direction would that be? Counterclockwise. And we can follow along this way.
What do you mean why?
It's
How the
opposite.
clock goes? You stinker.
We're saying we're naming it.
Can I hit her now? She called me a stinker.
I didn't mean that.
We could call this, listen up, we could call this polygon, we could start at, started at E, excuse me, so if you said E, started at E, we could go around either way. So we could go E, then you go D, C, B, A. You can start at any point, and you can go in either direction, but you just want to go in order around. You just don't want to skip one. So you don't want to go like E, B, A, C, D, or something like that. You just want to go in order from wherever you're at, one way or the other.
We have to write
So
up.
pick a point and just kind of follow along one direction or the other, and you name the
So
polygon.
it doesn't matter which direction you go?
Do we have to write up polygon every time?
Yes, to name it.
Abbreviate
Yep.
it.
We don't have an abbreviation for polygon.
Darn it.
L-G.
No, we
Poly. Poly.
no, we don't have an abbreviation for polygon.
We can make one.
No, we won't. Okay. So questions on this part. Okay, we're gonna go right below this table that's down there.
There's like 4 tables in this.
3 sides
There
is
are.
a triangle, 4 sides is a diamond.
Can be.
Wrong.
Can be.
Probably the name.
Okay. So the type of polygon. Not when it has 3 sides. What do we call those?
Triangles.
Triangles. We just got done with a couple chapters about that and just triangles, right?
Yeah, we're all done.
Okay. That's not true. So we're not going to focus on this chapter as much, okay?
Thanks.
But it's not the centerpiece anymore, okay? So when we have four sides, we're going to call it a quadrilateral. Now there are many different types of quadrilaterals that we'll learn about in this chapter, but we'll call it a
You
quadrilateral.
call it a quad?
Quad means what?
4.
Yeah,
Four,
four
okay? And lateral means sides. So this means 4 sides,
That's genius.
right? Okay. Does anybody know what we call it when it has 5 sides?
Pentagon.
A pentagon. Okay, penta is an abbreviation for 5.
Did we learn these in algebra? We
Um,
learned them in English.
probably not in algebra.
What?
You might have learned them just kind of in other classes along the way.
We learned it in English when if you had Beckman.
Why did you learn polygons in English?
No, we learned all these because he made us go through an entire book of
Yeah,
substances
that's
and
true.
we had to
We
write
had
down
a-
every single
Yeah.
We had
thing.
a 400
So,
question test.
For 6 will be hexagon.
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 Ooh, it's stunning.
8 is an octagon.
Okay, we'll get when we get there.
Please.
Okay.
7 is a
7 will be a heptagon. Heptagon.
Can you stop after that one, please?
How far beyond?
Shh. Don't need psychomists. Don't need psychomists.
My bad. New me.
Yeah.
Should get water.
Okay, to drink more water. Mr. Nelson.
Good to know.
I do, buddy.
Rhapsody. Ew, don't dab. That's like 2005.
See,
You just
that's
dab
what
push
we
ups.
were-
Can you still do them or did you get weaker?
Still do it.
We're good. I'm good.
You know the
Thanks.
Sharpie
You wanna throw hands?
Yeah.
8. Kylie, what did you say it was?
Octagon.
Octagon.
Stop sign.
Can we just put stop sign?
Excuse me.
Is that an O or an A?
It's supposed to be an A. And I
Octagon.
wrote O, and I'm like, that's not right.
That looks really odd.
My handwriting was really bad. You should see mine.
9 is called a nonagon.
Non, because no.
You don't know where you were going with
No, I did not know.
Okay.
I was
10.
gonna say no one.
What we called a decagon.
I knew that.
Yeah, I have a
Good.
Yeah, I was just gonna say, isn't a decahedron 12, or is that?
So decahedron is going to be about polyhedron, which are 3-dimensional versions of
There's a
polyhedron.
12-sided shaping.
So decahedron would be a
Are we gonna learn
10-sided
about that?
3-dimensional
Wait,
figure.
does that say it's 13-sided?
12. We're gonna skip 11. There's no special name for 11. It's kind of weird. Okay, it just like we have special names for 3 through 10, and for 12 we don't have a special name for 11. 12 is dodecagon. So it's like
Deer.
decagon. We just had doe, a deer, female deer.
What about, what is a dodecahedron then?
It's similar to the decahedron. It's a 3-dimensional shape with 12 sides.
Okay.
Where's 2? Quad.
2?
Yeah.
A polygon has to have at least two
Is that
sides.
What
an
the heck?
So
Yes.
for n number of sides, any number of sides, it's just a variable, a placeholder for whatever number of sides. So if it's any that are other than these, if it's 11 or 13 or 14 or 15 or 5,212, whatever,
Wow.
you just called it n gone. So whatever number of sides, we call it an 11 gone or a 13
Does
gone.
it have to be a lowercase n?
Yes.
You're
Yeah. N just represents our number of sides. However many that would be for this.
Why isn't it n
What
with
is this? So wrong.
Now we gotta name these.
No, we go to this
What?
page first.
Stop.
Don't do it.
I'm sorry.
Okay, so
Aha.
Thank you, Max. Appreciate
Dude,
that.
he's really boring me. Sorry for my feelings.
Ethan, stop being a bully.
We don't have side comments.
I'm not. He's making fun of me because my role
Our school
my
doesn't deal with
sister role.
bullying.
Because they go down
Was
here.
I looking at you? That's something to see.
No, but I was just saying.
She wants
So-
to fight me.
Polygons. We're gonna have two main categories of polygons.
I have Max's paper.
Like you.
No, it's fine. You can go on. I'm sorry. It's okay, Max.
So we'll have two main types of polygons. We'll have convex and we'll have concave. We're gonna talk about those definitions. I'm gonna ask you. It's not gonna make sense right away necessarily. Some it might, but it might take a second. And that's okay. I'm asking you to wait until we get to the definition.
Where am
So
I
a convex polygon is a polygon where no line that contains a side of the polygon contains a point in the interior of the polygon.
So pretty much.
And all vertices will point outward.
So, put
We'll
this
talk
in
about that.
simpler terms. So, the side of the shape doesn't have a point on it.
No, we'll talk about it. Just hold on. It'll make more sense in a second. So, first of all, copy what's there, and then we'll talk about the convex one. Then we'll do concave, write it down, and then we'll talk about it. So for a convex, we're saying no line that contains the side. So we're saying if you take this side of the polygon here, we have a polygon that's labeled convex, we'll talk about this one. If we take this polygon here, and we have a line, this line contains the side, doesn't it? The slide's inside of that line. Whereas like, does this line contain the side? No, but the one that's already there does. Okay? So if any of these lines that would contain a side, whether it's this one, or this one for this side, or this one for this side, if I drew it better, or this one for this side, or this one for this side, any of them. None of these will touch another side.
But they are.
None,
right now.
this one won't touch this side.
Oh.
This one won't touch this side, this one won't touch this side, this one won't touch this side. None of them will touch a point that's not on the side. Because this point's on both sides. It won't touch a point that's not on the side.
Oh. Should we draw that?
You can if you want, but you don't have to. You can just leave that one if you want. This is more just kind of a visual explanation. Good question. And if we look at these vertices, we have 5 vertices here, and they all kind of point outward. Okay, they all almost kind of look like arrows that point outward. It almost looks like if you were to draw an arrow from it, if you were to just make this into an arrow, it points out. This points out. This points out. And that'll also be true of a convex polygon. You can really tell by either. If one's true, the other's true. So you can tell just because everything's pointing outside. And this will make more sense in a second here when we talk about concave, which would be kind of the opposite. So a concave polygon is actually where it would be 2, it says 1, that's a typo, and this says of, that should be or, double typo. 2 or more of the sides cave in, so to speak. Cave in means they're kind of coming inside, kind of going inside. So concave is where they cave in.
Doing homework.
Great question.
Yeah, I like your tie.
Hey, thanks, I got it at Kohl's on clearance.
Nice.
Yeah. So I'm a big fan of paisley ties, so, you know, just the pattern of them.
It like brings out history.
It is, right? Yeah.
Wait,
Appreciate
when
that.
did you get it?
Oh, I got this one over the summer, I think. Part of when my mom
I was
posted the big mommy
show
strip.
y'all.
Okay.
Wait, what?
So the big mommy strip. So once again, extended sides. So just like we extended those sides on the convex polygon, if you have extended sides, I want you to write in extended. Yep. Extended sides, they can intersect. Some of them will intersect the interior of the polygon. They'll go inside the polygon. Yes. And at least one vertex here points inside. Once again, write this down, and then we'll talk through it, and it'll make a little more sense there.
Oh my Lanta!
So, if we look up here, when we extended these sides, none of these extensions, these lines, went inside of the polygon. They all stayed outside the polygon. None of them went through the polygon like this or anything like that. That didn't happen. But if we do this with the concave polygon, that won't be the case. So here, if I extend this side, oh, well, that's no worries. But if I extend this side, feels bad, man. If I extend this side, then it goes through this right here. It goes through the shape. It goes through the polygon right here. So it's so it's considered a concave polygon. I know.
That's it, yeah.
So this would be a concave polygon because if we extend this line, it goes inside. Whereas none of them did that over here. At least two of them do it over here, where they go inside, and that's not okay for it to be a convex, so it's automatically concave. And if we look at this vertex here, this vertex, does it point inside or outside?
Inside.
It points inside. Is that kind of what that last little bullet there says?
C.
Is that at least one vertex, sometimes only one, sometimes more, points inside. And that's true here. This vertex points inside. So after I explain both the convex and concave, those make a little more sense maybe in context of each other? Open so. Okay, does anyone have any questions on those two types?
That looks like part of crown.
This does? Kind of.
Yeah, looks like part of crown.
I like upside down. So an equilateral polygon is where all side measures in the polygon are
Equal.
equal in measure, which we call congruent. The sides are going to be congruent then.
Oh yeah, congruency.
Just like when we had an equilateral triangle, all the sides were congruent.
I see that symbol one more time.
You're gonna see it a lot.
I mean, you're going to see it right here in a
I don't
second.
even know what it means.
It means they have the same measure. And then
I
it's the
actually
same
wrote
measure.
equal.
Oh, I wrote equal to.
But they're not equal, they're congruent.
So equiangular polygons, all angle measures in the polygons are congruent. So they'll have equal measure. If they're congruent, by definition, they have equal measure.
I love my grandpa. I love
Good guy.
No, he just.
Wait, is it fine if I put they're all equal instead of that song?
He goes, I hope you're having a great day, sweetheart.
Put all equal measures. You can do that.
Text it, yeah.
Now, we can have polygons that are equilateral, where all the sides are congruent. We can have polygons with equiangular, all the angles are congruent. And we can have what we call a regular polygon. A regular polygon will be, excuse me, I started off the wrong one, will be convex, not concave. It'll be convex to where it points out. It'll be equilateral. Something on my words. Equilateral. And it'll be equiangular.
There's too many equal.
It'll be all three of those. For it to be regular, it'll be all three of those.
Okay, so
Yes.
should I put equal measures for both?
You're gonna do that. Otherwise, it'd be congruent.
You just put confusion. Am I getting the one big bullet here?
I already wrote it. You can't tell me to change after writing it.
I do.
Go ahead and pen this.
Okay.
It's actually right
He's
now.
actually getting you one, Marley.
Right now
Oh, that's
it's
awesome.
Marley, be thankful. He's getting you
right now it's worse in
Wow, Marley.
Venezuela than Africa.
Thank you.
Actually, Africa just got hit by the biggest tornado that they've seen in about.
Okay,
Yeah, well,
guys.
Mr. Wiseman gave me that beginning here.
Guess what?
So, for a polygon to be regular, it has to be convex, which means it's pointing all outward, not inward, not caving in. It has to be equilateral, all the sides are congruent. It has to be equal angular, all the angles are congruent. If it's those three things, then it's what we call a regular polygon. Now, regular polygon is typically what you're going to be thinking of, okay? Like a stop sign is an octagon, and that would be a regular one. All the sides are the same length, it's not like one side's bigger than the other. All the angles are going to be the same, and it's not caving in at all. So typically in the world, when you see polygons, they'll be regular polygons. Those are our most common ones we see in real life.
I would hope so.
So, now a diagonal, we're going to talk about definition of a diagonal. First day is pretty definition heavy. Diagonal, it's a segment that connects any two non-consecutive vertices. It's a segment that connects any two non-consecutive vertices.
I'd be getting up an hour ago.
I still got a day.
So-
I'd be getting up an hour ago.
It didn't make sense.
She said I'd be getting up an
Not
hour.
I'm.
So
Ooh.
here,
I feel the tension.
drawing all diagonals. So for this, first of all, what kind of shape is this?
That is a
Even
A
if
pentagon. So it's a polygon, but more specifically, it's a pentagon because it has five
Five
sides.
sides.
So we're gonna draw on all diagonals here. So can I get a volunteer to come up here and draw one of the diagonals, Kennedy?
Tracy.
Yeah.
Tracy.
They can't touch, is that right?
It has to be. It has to connect two vertices that don't touch. That are next to each other.
Do you want me to do an arrow?
Just draw like a straight line.
Sir, can I go to the bathroom, please?
Can you wait a couple minutes?
Do you
You
have a
wait
friend?
17 minutes.
Do you have a friend shirt on, Kennedy?
Oh, no.
So if that's straighter, that'd be right.
Oh.
Sit down here.
Come on, let's not like this.
Kennedy, do you have a friend shirt on? I like friends.
There you go. So that would be an example of one diagonal. Now volunteer draw another diagonal. Sophia.
New Year's Eve.
Okay. New Year, not New Year.
I said New Year. Yeah, I can't. I can't say
Nope. It's just gonna be. It can just go like this.
But they can't intersect.
Well, so here they can, but it has to connect two non-consecutive vertices. So here we'll draw on every single diagonal. There is.
What is that?
That's pretty good.
Yep.
There you go, Mark.
So we're just drawing in every single diagonal on the first one. Don't do the second one yet. On this first one, we're drawing in every single diagonal.
Guys,
So we're
we
gonna have
are
some
pro
overlapping. That's
liners.
okay.
We're
Another
pro
volunteer.
Can they go across the light?
Anybody wants to volunteer again? Anybody else want to volunteer for the first time?
Kennedy, Gracie, go. Gracie, go.
Hey, Max? You want me to guess your color for you?
No, Max, that's my color.
Oh, you stole his color.
No.
Which one are we doing?
You can pick your color if you want.
Are we still on the same one?
He said
What? Whoa! You're changing it up.
What?
I'm not very comfortable with that, Max.
What did he just say? I know it's peace note.
He said he should be expelled for that. There you go. That'd be one we haven't done yet. I believe there's one we haven't done yet. Nick, you want to do it?
This is too much.
Is somebody
Montez?
Is this
Us in?
Order, David?
I didn't do near as much as I should have. And then not Star David. Star David has 6 sides.
I was thinking that same thing.
Hey, so here we drew in every single diagonal here,
Look
okay?
at the star.
And there were 5 diagonals for a 5-sided figure. In this case, it's not always gonna be that way. We're gonna do one more here. So here on the second part, we're only gonna do it from vertex C now. We're gonna do it from vertex C now. So it's gonna be different. We're not gonna do it from every vertex. So is there a diagonal from C to B?
No.
No.
C to A.
But C to A has one.
C to F.
C to F
E.
and C to E. Does C to D have one?
No.
No. So how many diagonals were there from point C?
Three.
Okay. Yes, both of you. And both of you girls can fill out your password.
I'm gonna sharpen my pencil.
Let's write that.
Once you draw these in, go ahead and flip the page. Once you draw those in, go ahead and flip the page.
Oh yes, we love charts. Hey,
Good.
Mr. Boss loves his charts, and I go to the bathroom. Actually,
I say we need to go pee.
I always wanted ready to go back, and I go.
I don't watch it.
I'm so upset because they're finally ending it. It's only been
Baseball games now.
15 years.
Yeah.
15.
I'm still shook that Grey's Anatomy is still keeping it.
I still shook that Grey's Anatomy is keeping me going as possible as you.
Oh,
I still
man.
shook that Grey's Anatomy is still keeping me going as possible as you.
Stand that show. It's so.
Oh man.
I love Grey's Anatomy.
I'm rewatching it for the fourth time right now.
How are you watching it for the fourth time right now, Mr. Carlson?
What's up?
You?
What's up?
Not much.
Same.
Just talking into the recording.
Same with that.
The sky is falling.
All right.
Oh, we get shapes.
Yeah.
Yeah.
Happy fun time.
I
Give me kindergarten.
have two.
Probably. All right. So you guys, most of you guys are kind of near somebody, and I'm gonna have you guys in your partners work on something here. Can they please put that away?
Who's gonna be my partner?
Okay.
Max.
I know you're trying to
I
send
got
a
you.
picture of your grandpa. I get that.
I was actually. Like I'm not kidding you.
I really don't doubt that.
I was actually.
Yeah, that's what I'm thinking. That's why I said
We
that.
wanna.
Okay. So Nick, I'm gonna have you slide up here.
No, he said, I know you're trying to take a picture of me and send it to Graham, but I was like, I actually was. I was trying to put a filter.
What?
Merry Christmas.
Yeah, it'd be crazy.
Yeah.
Yes.
No, I don't break it.
Oh.
Okay.
I was putting a filter on you, and I was gonna be like, I'm in his class.
Okay. Let's not do that during class.
Okay, after.
Liz will have you Marley. Okay. I'll have you work with Cynthia.
Emu.
Woo.
Emu.
Emu.
Yeah.
Third page here.
Don't forget about Lily. Oh, yeah. There's Lily too, sir.
There's 8th grade. That's not even that long.
I know, but I still called her that.
Max,
But if you really think about it, it was pretty
It's a
long
boy.
It was
ago.
almost 3 years ago.
Yeah.
Nearly.
I'm with Kennedy.
you're gonna be together.
Yeah, Kai and I are together.
Yep.
You guys remember that jail trip?
We have a,
Alright. Hey, so each group, each pair has a shape, has a polygon. You have different shapes, okay? So I need each group to have one protractor. There's some protractors over here. I'll grab them, pass out here. Okay, each group will have one protractor. And we'll go through and we're gonna measure the interior angles. Now if you look, see, I'll pass it out real quick.
Oh, I know.
that's what I did it for a while.
Wow.
Is that like, you'll see.
Alright. So let's first talk about how I want this chart to be filled in. Everybody focuses up here real quick. We're talk about how I want this chart to be filled in. So we're gonna do this, the first one together. So this polygon shape, what's the name of it?
Triangle, 3 sides.
A triangle. So we'll first fill in the name with triangle. And then we'll say, okay, well, how many sides does this have?
3.
3. And what do we know about the sum of the interior angles? All the angles inside, we add up to 180. And so if the measure of each angle, if the polygon's regular, regular means that it's going to be equal angular.
180.
So what's each angle going to be if they all have 180? 60 degrees. How could you figure that out if we don't know it?
60 times 3 is 180.
Okay, we could take the sum divided by the number of angles there are, which is going to be the same as the number of sides, right? Because there's 3 sides, there's 3 angles. Just like here, there's 4 sides, there's 4 angles. So you can take the sum divided by the number of sides and get each one. So maybe write that little note here. Take sum divided by number of sides to get this. And we'll fill in the last one later. Now, each of you guys, or in your pairs, have different shapes. So for example, what shape do you have?
Hexagon.
Hexagon. Okay, I heard hexagon. So the group that has hexagon would go through and fill out this one. They would find out, they would say, okay, here's the name, here's the number of sides, and then they would measure using the protractor together. Okay, you obviously can't hold it together, but you can help each other measure it. Take turns measuring angles, and you would measure each angle and then add them all up. So you might want to use a calculator as well. Now, some of these shapes, you might not be able to measure it very well. So how you would do that? This one up here, focus up here. How you would do that is I would hold this up here, and then I would take some sort of straight edge to extend this side out. So maybe I have here another protractor, so I can take another protractor and extend this side out and say, oh, well this side now goes out to this measure here, and then I would write that down on the shape, and then I go to the next one. And you guys can feel free to write the measure down in the shape where it's at. So you find the measure at each angle, and we'll keep going. So I want you in your groups to work on that. And as you need help, please raise your hand. And when you're done, I'll ask you to sit quietly. But go work on right now, find the measure of the angle. Willie, I'm going to have you partner with William back there.
Mr. Costa, where are we only gonna do the one shape?
What do you mean?
One shape like this. Are we supposed to find it on here and do it?
So which shape is it? What shape is it? Okay, well, but on there it's a
Emma.
what do we say in our chart? Quadrilateral. So you write that on. Okay. Yes.
Oh, I took that.
Here, we use what you do. You line it up on both sides.
Oh,
And this goes
that's
out.
all. Think about
No, so it means
Divided by the number of sides.
line this up on it. Paper sheet. Line it right here.
1999.
So it goes through right about so it's for a bigger side. Well, the bigger side is here.
Keep
It's
moving.
90 around.
Where do we put it?
Let's look at the same two. So we start here at 0 with the parts. All the way up. Starting at 0, so we top.
How do you find the stone? What'd you say? How do you find the stone? Right here? Add them all up.
You write that here. On the sheet.
No,
Onto
I never
right
understood
here.
But
So each size 100.
And then you add them all up.
Now do we add, so 104 times 5?
You don't know that. You measure it through it. Okay, and then you go here and you do the next one. The next one, the next one.
520.
no, I need help.
Yeah.
Oh, which way for us?
Just do.
Each of these, 90 points, right? And then you would add them up.
Yeah,
One,
right.
and then the sum of
But
these.
you don't know that. So you measure it here.
Wait, right here, wait, this one?
But we'll start off with this side.
Yeah.
You measure.
What the?
Put this little crosshairs
Is that an F?
on this vertex.
It's a weird 5. That's what I'm
We did, check money.
Four. We say, okay,
What is
here's
this?
our board. So you write that in.
Oh, God.
And then what do they add up to after setting this box?
Mr. Coswell, I am not doing this right.
Oh,
So we'll use the protractor here. So we'll place it on the vertex. We'll hold all the vertexes.
Yeah, I ran out of my planner. I lost it. I don't know where to go.
You lost what?
What is gonna be mine?
Not every teacher does well.
You lost your family, but to be honest,
Yeah, not every teacher
What
does
college
I
are
would
you
use
in?
that on my
Not
birthday.
copying.
Yeah, you are.
2
G money.
Okay. We're gonna start talking about this. Okay. Next, were you having a question?
No, it's fine.
Did you have a question, buddy?
Max, what was your question?
I'm fine. Sorry.
It's okay, fine. It's possible. So, raise your hand if you had the four-sided figure. Raise your hand if you had this four-sided figure. There were a couple groups with it, I believe. Maybe just one. Okay. So, what was the name of the four-sided figure? Quadrilateral. Okay. So this is for the four-sided figure group. Okay. And we said, okay, yeah, it has four sides. What was the sum of the interior angles you got?
No, 360
Okay,
degrees.
360 degrees. I agree with that. And so, what would the measure of each angle be if it was regular?
90 degrees Celsius.
90 degrees, not Celsius, not temperature. Just 90 degrees because it's an angle measurement.
If it was 90 degrees Celsius, we would die.
Okay, so
Not necessarily.
they might not be regular. They might not have a regular polygon, but if a quadrilateral was regular, means it's equal angular, then it would be 90. Each angle would be 90 degrees. Okay. Raise your hand if you had one of the next ones. If you had the five-sided figure, raise your hand if you had the five-sided figure.
I did.
Okay, so William, Lily, and Max should be raising their
Pentagon.
Lily, William, and Alicia should be raising their hand. Okay, it's called a pentagon.
5 sides.
Voice off, guys, unless you're in this group. 5 sides. And what did you guys get for the sum of your interior angles?
565. 575. 525.
520.
Okay.
Not right.
So, you guys had it too?
Yeah.
Okay, what did you guys get?
We got 520.
520 is closer. What did you get, Alicia?
575.
575 is kind of between those two, okay?
550. 550.
Okay, it's going to be 540 degrees,
I
okay?
just said that.
Good job, Gracie.
You said like 3 different numbers in a row.
Yeah, but she still got it right.
Okay, so it's going to be 540 degrees would be the one I want everyone to write down. I want everyone to write 540 degrees. These were close, but I want you to write 540 degrees down. Okay? So, what would that mean? One of these two groups. What would each angle be if it was equal angular then? So go ahead and do the math real quick.
108.
108 degrees. Thank you.
Yeah, G money.
I knew you could do it, G-Money.
Okay? So for the next one, 6
Oh,
sides.
This one's hard.
Okay? Raise your hand if you have that.
Kylie.
Okay? Kylie and Kennedy, and then Nick and Julia. Okay? So what was the name of this one?
Hexagon.
Okay? Hexagon.
6 sides.
6 sides.
Don't ask me the other question.
Okay? What did you guys get for the sum of the angles?
I got 690.
Okay, 690. Is that what both of you guys got then, I assume, together? Okay. And did you guys end up finishing it?
No.
Okay.
I mean, yeah, but it
What did you guys?
Wouldn't it be 720?
Okay, what's your reasoning?
Okay, if you add 180 to all of them, then
Alright, okay.
It's 720.
We're noticing something, I like it. This one is going to be 720.
73 beats per minute.
This one would be 720. All hexagons, the sum of the interior angles would be 720 degrees. So that means this measure of each angle in a regular hexagon would be 120 degrees. You take 720 divided by 6.
Would you have to memorize this?
No, but it's for a pattern we'll see here in a second. Some of us are starting to see it. Okay, we'll go on to the next one. 7 sides. Raise your hand if you have the 7-sided one. Okay.
Oh, wait, no.
Heptagon
Okay, Marley and Lizzie. Okay. What was the name? Okay, heptagon. Voices off, guys. Number of sides was 7. What did you guys get for the sum?
Nobody did that.
910. Okay, that's pretty close.
920.
Okay. I'll say 900 exactly. Okay. So pretty close. Okay. That's about a degree off per angle. So that's pretty common for rounding error, I would say. Take a degree off.
128.5.
Okay. So that ends up being approximately 128.6 if you round. So this one doesn't work out exactly. This one ends up being approximately 128.6 degrees.
Yeah, but Mr. Cussel.
We'll be okay.
You add like 200.
This is when my.
Okay. So raise your hand if you have the 8-sided figure. Okay. Paige and Christine. Okay. So what was the name of that? Octagon. Thank you.
Do you just add 180 every time?
And what was the sum of the interior
I'm
angles
so
here?
smart.
Very good, 1080. And so what was each angle then? 135, exactly right. Okay. Raise your hand if you have the last one, our 10-sided figure, okay, max to max.
1,000.
Okay, so the name is decagon. What did you guys get for your sum of angles? Did you guys quite finish?
What? That's what?
This is probably wrong, but we got 1,400.
I won't quite agree with that one.
1,200.
You said 1,430? That's really close. That's really close, okay? So,
Really close?
it's really close, okay?
No, 1,430.
It'll be 1,440 degrees, okay?
The last two were
Uh-huh.
consecutive.
I know. We'll talk about it. So what would that be if each angle was the same? That would be
144 degrees.
144 degrees. Okay. Now I heard some people talking about kind of the pattern. Emma, what was something you were seeing?
On the first, he was not counting the last two.
Okay.
If you added 180,
It went up by 180 each time, right? So every time you added a side,
is that the rule?
you went up by 180. Okay.
The sum of interior angles.
Everybody focus up here right now, please. Thank you. Every time you went up a side, you went up 180 degrees here as well. Don't put it away yet. Don't pack up
No, I
yet.
got a question.
Okay. I hear people packing up. Please don't. And it keeps continuing here. But it changes right here. Well, how many does the sides go up from 8 to 10? 2. So would it go up 180 still? No, it would go up 360, which it does. So that's the change there, because you skipped 9.
Wait. 144 does not make any sense.
Okay, take 1,440 divided
Oh,
by
that's 10. I got 9.
10. Okay. Now, the reason why is right here. We'll make this last column that we haven't done yet. We'll fill it in. We'll call it the number. Guys, attention up here for the last couple minutes, please and thank you. We'll call it the number of triangles. Okay, well, how many triangles are in a triangle? Just one. Okay, and we know the sum of the interior angles of a triangle is 180. Now, if we go make one diagonal here, only going from one point, how many triangles do we have here? 2. Well, if each triangle is 180 degrees, then 2 triangles would be 360 degrees. You double it.
No, 3.
And if we go from here, we go from one point only and draw diagonals, one point only and draw diagonals. How many triangles do we have here? 3. And so you do 3 times 180,
Then it's 4.
which would be 540. If we go in the hexagon, draw all the diagonals from one point exactly. How many triangles do you have?
4.
4. And if we do 4 times 180, we'll get 720. Okay? And if we continue that, how many triangles are going to be in a heptagon?
5.
How many triangles are in an octagon?
6.
How many triangles are in a decagon? How did you get that? Okay, what can we do from the number of sides? What can you do from the number? Subtract 2 from the number of sides, and you get your number of triangles. Okay, today there is a homework assignment. You guys can pack up your notes as I pass this one out. For this homework assignment, you are figuring out what kind of polygons we have. You're figuring out what kind of polygons we have here.